Welcome to Lesson 10.4. This lesson uses factoring and the zero product property to solve quadratic equations. The zero product property tells us that if we have two things multiplied together, such as A and B, and we know it equals 0, then either A or B has to be 0. Think about it. 5 times 0 is 0. 0 times 5 is still 0. So if we have a product and we know it equals 0, then one of the two items that are multiplied together has to be 0. So the zero product property allows us, if you look at this quadratic equation, notice it's already factored for us, and it equals 0. So the zero product property tells us that either 2x plus 3 has to equal 0, or x minus 4 has to equal 0. So what we can do is we can place each of the factors equal to 0 and solve for x. We can subtract 3 from both sides here, and we're left with 2x equals 3. And if we divide both sides by 2, we get x to equal 3/2. Or over here on the other side, if we add 4 to both sides, we get x equals 4. So our two solutions are x equals 3/4 or 3/2 or x equals 4. That is using the zero product property to solve. You could also graph this equation and then find the zeros where it crosses the x-axis, and that will give you the same solutions here. But you can see how using factoring, or when you're given the factors, it's pretty easy to set them equal to 0. In the next problem here, we do not have the luxury of factors. However, you have the skills to factor. You can factor the x squared plus x into x plus, what numbers multiplied together give us 42? 7 and 6, right? So x plus 7 times x minus 6 equals 0. And then again, set each factor equal to 0. X plus 7 equals 0. And x minus 6 equals 0. And then we subtract 7 here, and we get x equals -7. And over here we get x equals 6. If you want to take a moment, I have this all typed up neatly because of my mouse pad isn't the neatest. If you want to pause this and kind of take down some more notes, then I'm going to put the next slide up now. Here you go. I've got this all typed up, and you can see how we are solving these. That should be a minus sign right there. And we get x equals -3/2 or x equals 4. I think I made a mistake over here. Yep, I lost my negative sign here too. -3. Okay, so here we've got this. You can go ahead and pause it and take some notes. Scrolling down to the second example, here are the solutions for that. Go ahead and pause it when you need to. You can also plug each answer back into the original problem to check and make sure the equation is still true. Hopefully you've restarted me now, and let's check the next example. So our next example, we have a word problem here, and we've got the length of a box. And here's our little picture of our box. And they tell us that the area of the sheet is 130 square inches. And we know we're going to cut these little corners out so that we can fold the box up so we have a lid or an open box. So what we want to look at here is, what is our total dimensions? Notice in this side, if this from here to here is x, that means the total side here is going to be x plus 2. Okay? And then the length is going to be, here's x plus 3, plus you have to add another 2, so we get x plus 5. And we know that those two factors, what do they equal? Well, they're going to equal the area of our sheet of paper, which is 130 square inches. So now what we're going to have to do here is we're going to have to solve this, and let's solve it for x so we can figure out the actual dimensions of this box. And we FOIL x plus 2 times x plus 5, and we get x squared plus 7x plus 10 when it's all said and done equals 130. Now, in order to solve by factoring, we have to have our equation equal 0, and it doesn't. So in this case, we're going to have to subtract 130 from both sides so that we now have it equal to 0. And I'm running out of space here. So we end up getting x squared plus 7x equals, that's a 7x, equals, minus 120 equals 0. So now we need to think of factors of 120 that have a difference of 7. And I'm thinking 20 and 6, no. 10 and 12, no. What about anything you can think of? How about 8 and 15? Oh yes, those will work. So we can take x plus 15 times x minus 8. If we set each of those equal to 0, we get x equals negative 15 and x equals 8. Can we have a negative 15? No, we can't. So 8 is going to be our answer for x. So that means 8 is here. 8 plus 3 is 11. That's going to be the total dimensions of our box. And then the height is obviously 1. Here is the answer typed up for you. We can see that our box then is 8 is our only reasonable solution, not the negative 15, and then we've got a 1 by 8 by 11. When you're ready, go ahead and do the quick checks and restart this to check your work. And here we've got negative 7 and 4, y equals 2 or 5/3, and then x equals 12 or negative 4. So you can see here how graphing might be okay for something like this, but to get an exact answer here that is not a repeating decimal and that's something you're going to round, you're going to need to factor in order to get that exact answer, and I will expect exact answers here. X is 12 or negative 4, and then here is a problem just like the previous one we did. In this case, our box is going to be a 2 by 9 by 10. If you're having trouble with this, imagine that here is the box, okay? And then it says that the width is x, and that this side is going to be x plus 1. But now remember, we have to add 2 inches to each side instead of just 1 in the previous problem. Okay, so that means this side here, this is 2 and this is 2, and then so our whole side length is going to be x plus 4, which is right here, and then this side length, because this is 2 and this is 2, this side length here is going to be x plus 5. So that's how we get those side length dimensions. Great job. Let me know if you have questions. Please write them down or send me an email.